Okay, there's enough space at the top to do 4 warm-up problems. Nah, we should do 4. And I think that's all the possibilities of evens and odds exponents. So, try those 4, and then, it's easy to get the answer, I guess. The main point of those is to get whether it needs absolute value or not. So that's the main thing. Obviously, I hope you know the cube root of x to the 9th is x cubed, but then does it need the absolute value or not? So all of those have nice answers. The question is, do they need the absolute value thing? Okay, so some of you have right answers and are trying to come up with a rule. Some of you don't have right answers and coming up with a rule, so that definitely wouldn't work. But I still don't like the rules are complicated. So I don't like trying to find a rule. I like thinking about the problem. Let's first, the cube root of x to the 9th. So forget about the absolute values for a minute. What's the cube root of x to the 9th? X cubed. Okay. Now, let's see it. If I plug in a negative number, x to the 9th, that'll be negative. A cube root of a negative number is negative. So I don't want an absolute value in here. I want to get a negative number. If I plug in a negative number, I want to get a negative number out. So I don't want absolute value on that one, because I want that negative to be preserved. That negative does not get wiped out, so I'm not going to wipe out the negative. All right, number 2. Cube root of x to the 12th? X to the 4th. Let's see. If I put in a negative, I think we can just look at the end here. X to the 4th is always going to be positive anyway, so it doesn't matter. That's probably the start of a rule right there. If the answer is even, there's no point of absolute values anyway. Okay? So maybe we can try to build a rule. I think there's your first rule. If the answer is even, then absolute value is pointless anyway. It's okay. You're trying to figure it out. It's all right. All right, number 3. The 4th root of x to the 20th, what would that be? X to the 5th. Why do I need absolute value on that one? X to the 20th is going to be positive. The 4th root is going to keep it positive. That means if I plug in a negative, I need a positive answer. But x to the 5th would give me a negative answer, and I don't want a negative answer. Absolute value. Okay? 4th root of x to the 24th. X to the 6th. Why are we good, Cooper? I agree we're good. Did you say we're good? Or did Ryan say that? Jack, why are we good? So what about even makes it good? It's going to be positive regardless. Okay, so if you guys want a rule, we can try to come up with one. I think the first thing is if the answer exponent is even, then no absolute value bars. Right? Because it's pointless. You're going to get positive anyway. So if your answer exponent is even, no absolute value bars. It doesn't really matter prior to that. If your answer exponent is odd, well, then you got to be careful. This is why I say I don't like making a rule, because it's like a 3-step rule that I don't think is worth trying to figure out. I think it's just worth thinking about what happens if I plug in a negative. Carson.
So for the first one, because it's odd,
Because what side? Let me stop you.
The degree, the exponent.
Which? The initial or the answer?
The answer.
Okay.
You can't have like absolute value on it. Like it wouldn't be like the same thing like number 2.
Well, 2 and 4 I don't need absolute value because x to the 4th and 6 is always going to be positive.
Yeah,
so that would be like redundant, excessive, unnecessary.
But you can't do that for like number 1. Like if you wanted to, like I don't.
Number 1 might be negative, and it's okay if it's negative.
If you put like absolute value x to the 4th, like if you put it in there, that's like a fine answer, right? Technically.
Okay, so you're asking if you put absolute value of x to the 4th, is that okay? I guess yes, because it's not wrong.
Okay.
It would be like if your final answer was 12, and you told me the final answer was the absolute value of 12. I'd be like, well, yeah, unnecessary, but not wrong.
Question 1, you get a -1.
Yes.
So you don't like.
But if I put absolute value bars on there, I wouldn't get -1 anymore.
Positive. So.
I want to preserve the negative.
Okay. So like, if I don't like, how would you know if you plug in a number? Like, how would you check it to make sure that you're doing it right?
So. Exactly what you said. If I plug in -1 to the left-hand side, I get -1 to the 9th. That's -1.
Yeah.
Cube root's -1.
Do you just want it to stay the same? Like, if the x is -1, you want the x at the end to be -1?
Well, if this tells me that should be the case. If I plug in -1 to this one, so cover that up. If I plug in -1, what's my answer going to be? Uh-huh.
So that's like.
But if I have just x to the 5th, that would be -1.
It's positive because of the exponent. That's when you put the absolute values on it.
Correct.
Okay.
If it turns a negative into positive,
Yeah. So like if it stays negative, you don't need absolute value.
correct. You want to preserve the negative.
That makes more sense now.
Okay. So I mean, I think I could come up with a rule. I just don't know that it's worth it. Like the first step is fine. Like if your answer is even, no absolute value bars, they're not needed. But if the answer is odd, then it depends on
What's under the radical?
yeah.
Basically.
Yep. So it's like a 2-step rule if you're going to memorize a rule. First look at the answer, but it's like an if-then statement, right? If even, then no absolute value bars. Else if, well now we got to look at something else.
So like if odd, go to step 2.
That's right. If your answer is odd, then we got to go to step 2. Is it worth coming up with a rule, or is it better to just think about what happens if I plug in -1?
Okay.
Yes, no, better? Better? That's about as good as we can get right now? Maybe we'll do some more of those tomorrow. Well, not tomorrow. Okay, some notes. Like we sort of hit on a little bit of this yesterday. Like if you know these numbers, it makes taking square roots and cube roots a lot easier if you know the powers. So like numbers you need to recognize. I don't know. Do we need to pull popsicle sticks for this? Why don't we just cruise through this? 2 squared? We'll go through the 2's and then the 3's rather than all the squares. So 2 cubed, right? It's easy to do it this way because you can just write them down because we're doubling as we go down here. So there's our powers of 2. So it's good to know those so that if you see the 5th root of 32, you're not sitting there thinking and counting and trying to figure it out. You're like, oh yeah, I know that 2 to the 5th is 32, so the 5th root of 32 is 2. So again, helpful numbers to know. You don't have to have it like completely memorized, but at least recognizable. 3 squared is 9. 3 cubed? 3 to the 4th?
81.
3 to the 5th?
243.
Again, you're just multiplying by 3 as you go down. You probably don't have them memorized. Just multiply by 3 as you go down. But now that you see them, hopefully they're in your brain a little bit. That way, if you see 243, your brain can go, wait a minute, that's the power of 3, and then you can figure out what it is.
Yeah, when multiply by the same number and then get the
So you multiply to get the next one. 4 squared is 16. Multiplied by another 4 is 64. Multiplied by another 4 is 256. 5 squared is 25. Multiplied by 5 and multiplied by 5 again. And the numbers start getting really big, so we stop doing, fourths and fifths, and we drop down to cubes, and eventually we don't do those either. 6 squared is 36. I know that one. 6 cubed? 216. Karis, you said that pretty quick. Did you know that, or you already did the math out? That's fine. 7 squared is 49. Times another 7. It's 343, and 8 squared is 64, and hopefully 9 squared and 10 squared. But 8 cubed, that would be whatever 64 times 8 is. That's too big. A big number, yeah. So again, you don't really have to have those memorized. If we ever ask for them, you could figure them out. But it's good to at least recognize them, so when they show up, you're not completely guessing on what power we got there. You hopefully recognize that 625, and like, oh yeah, that's 5 to something, and then maybe go figure out which 5 it is. Okay, rational exponents. Again, rational has the first 5 letters of ratio. That means fraction. So some fraction exponents today. All right, we know that the square root of b squared is b, right? The square and the square root cancel each other out. This is side note. Does this need absolute value bars or not? Think about a negative. Why not? You're right, it does not. Because it's got to be, you can't take the square root of a negative number, so you don't have to worry about negatives. That's tricky because if we did this the other way, what about that? No plus or minuses. You're only allowed one answer. When you get B, but absolute value of B?
No, because it's going to be positive.
If I plug in -1,
You get 1.
I get 1. That means I need to make this positive. We'll keep working on that. Okay, power to a power we multiply. So what would need to be in this box if we multiply those two things to get 1? 1/2, right? 1/2 times 2 is 1. So now look at those two things. Like they both equal B. So that means that this and this are the same thing. The square root of B is the same thing as B to the 1/2. The square root of B is the same thing as B to the 1/2. That bottom number, I think we get this later, but we'll go ahead and say it now. The bottom number is the root. The top number is the power. And a math teacher that used to teach here a few years ago, I don't know if this was original or not, but he would say, the root grows underneath, and the flower power grows up top. And you're like, well, that is really dumb. I mean, yeah, but it helps you remember which one's which. Because right now, maybe it's obvious, but we start doing some of these other ones, you like, whoa, there's numbers, who goes where. The root grows underneath, just like always. The flower power grows on top. So, let's work on going back and forth between radical form and exponent form. And right now you probably prefer radical form, but before long, I mean maybe not a matter of days, but like later math classes, we definitely prefer exponent forms because there's more math you can do. Radicals, you're kind of stuck. Exponents, you can do stuff with. So what's another way to write? I mean, I know the square root of 25 is 5, but that's not what I want. I want to write the square root as an exponent. So 25 to the 1/2. How about the cube root of 10? The root 10 to the 1/3. Because it's 10 to the first, that's the power, but the root is 3. What about the 5th root of x squared? So Ryan, what you said was right, x to the 1/5 all squared, but we'd rather just write it as x to the 2/5. Flower power grows on top, root grows underneath. Goes or grows, I guess. Now we got to think backwards a little bit. The answer is y to the 3/4, but same thing, the power grows on top, the root grows underneath. So y cubed is on the inside, and we're taking the 4th root of y cubed. We'll label it one more time. Almost labeled it the flower. The flower power grows up top, the root grows underneath, so the nth root of a to the m. All right, part A, evaluate without a calculator. Yeah. So what does the power of 1/3 mean? Cube root. So some people will just think in their brain cube root and then take the cube root. Other people are like, wait a minute, I need to see that before I try to evaluate it. So that step you don't have to show, and it sort of depends on the difficulty of the problem if I'll show it or not. After this one I probably won't show it, but sometimes it's helpful. So the cube root of 125. So what number do we cube to get to 125? 5. 8 to the 2/3. This one I would probably write out because I don't want to do like two things in my head here because that's squaring and cube rooting. But it's almost always to do the root first. Almost always. So I'll say usually evaluate root first. Oops, that way you can read it. That's how plants work too, right? The root grows first, and then the flower pops up later. So that's not why we do the root first. Do you know why I say do the root first?
Makes it easier.
Makes it easier. How does it make it easier?
Simplifies it out.
Yeah, it makes your number smaller, generally, first, and then you can square it. It's like, this is an easy one to show either way. So the cube root of 8 squared. Now, the cube root of 8 is 2. 2 squared is 4. That's the root first method. And again, once you do a bunch of these, some of you will do all of that in your head. You'll be like, cube root of 8, that's 2. 2 squared is 4. I don't need to write any of that. That's okay, just be careful. If you do the power first, this one's okay, right? 8 squared is 64. And the cube root of 64 is 4. But then you get to one like C. Well, I guess first of all, what's the negative do? Flips it. So let's go 1 over 81 to the 3/4. And now I think we have a clear choice. Would you rather do the power or the root first on this one? I agree, because I do not know what 81 cubed is. And even if I did, it'd be tricky to take the 4th root of whatever that big number is. Instead, let's do the 4th root first. Again, some of you are going to get to where you do this in your head, and that's okay. Be careful. What's the 4th root of 81? 3. That's why we went through these earlier. And 3 cubed, oh, this is a popular one to miss. 27. You know what the popular wrong answer is?
Multiply by
9, yeah. 3 to the 3 is 9. 3 times 3 is 9. Wait. 3 times 3 is 9, but that's not what we're doing here.
3 squared is 6.
For some people, some days.
Not some days.
Why don't you try D and E? Tricky. Maybe. So the negative exponent flips it over. I guess I did 2 steps at once because I also wrote the denominator 4 as a root, the numerator 3 as a power. It is froze. I didn't unfreeze. There we go. Yeah, because I don't want to do 16 cubed first. I don't know what that is. 4th root of 16 I know. That's 2. And then 2 cubed is 8. And again, there are going to be some of you that try to go straight to the final answer without showing anything. If you get it right, fine. But if you get it wrong, for one, I can't give you any partial credit because there's nothing to grade there. For two, hopefully you show a little bit of work to help, almost slow down your thinking rather than try to get it go fast and jumble something up and mess something up. Okay, a lot of things going on here. So negative exponent, I'll flip this thing over. So negative 8/27 to the 4/3. And I guess I need to put the negative on either the 8 or the 27. It doesn't really matter. Negative 8. Again, cube root first, probably preferred. Definitely preferred. I don't know what 8 to the 4th is. I do know what the cube root of 8 is. Oh, be careful with the negatives. But when I 4th it, it's going to become positive, so that would be 16 in the top. And then the cube root of 27 is 3, and 3 to the 4th is 81. And by the way, I know 16 over 81 doesn't reduce, because 16 is made up of a bunch of 2's, and 81 is made up of a bunch of 3's, so there are definitely no common factors in there. And that negative became positive. Some of you saw it right away. You're like, hey, if we raise it to the 4th, anywhere along the way, it's going to wipe it out. And that's fine. Okay, and then we get to just letters, and sometimes this freaks people out, especially with fractions. But what do we do when we have a power to a power? Multiply. 2/3 times 6. Oh, some people don't know how to multiply fractions. That's frustrating. Top times the top, bottom times the bottom, right? Don't do 6 times 2 and 6 times 3. That's the favorite mistake. 12 divided by 3 is 4. The people who make the mistake, this is one of my all-time favorite mistakes. Usually they write it like that, and so they think the 6 goes to both. And so they get 12 over 18, and then they're like, oh look, 12 over 18 reduces to 2/3. And then they box that up without engaging their brain and thinking, wait a minute, I just did 6 times 2/3 and got 2/3, right? Hopefully you think, wait a minute, that doesn't seem right, because that's not how we multiply fractions. I mean, that's how some people multiply fractions. That's not how the right people multiply fractions. All right, letter G. What's 1/4 times 3? 3/4. I'm a little disappointed this one doesn't specify directions on how it wants your answer. So that's the exponent answer, which is fine because it didn't specify. What would the radical answer be? 4th root of x cubed. That's a radical answer, man.
Does it matter if the cube is on the x or if you put it outside of it?
Oh, that's a good point. It would not matter if you wanted to do the 4th root of x cubed. Yep, same thing. All of those are equivalent. Again, just be careful sometimes we ask for the exponent answer, sometimes we ask for the radical answer. This one didn't specify, so I have to accept either one. Oh, I don't know. Yeah, something got printed weird, because like you can see the H and the I. It's like from here down, you should erase that. If you can ignore that, right there's H right there. So I don't know what happened on the printer or something. 4 through to 81? 3. And what about the 4th root of x squared? Let's rewrite that. This is why we like exponents better usually. If I write that as an exponent, it's x to the 2/4. And then you're like, wait a minute, I know what that is. That's 1/2. What's another way to write 1/2? Yeah. Again, this is why I think I said earlier we usually prefer exponents to radicals, because you can do more math with them. It feels like you're stuck with the 4th root of x squared, but when you turn it into an exponent, then you see that it can reduce. All right. What do we do with n to the negative 2/3? Flip it, and then I guess we're done, because there's... Yeah, I mean, you could write it the other way, but the cube root of n squared, but there's really no reason to write it that way unless it specifies to give your answer in radical form. We're not going to worry about that, because fixing that, do we have to worry about that? Shoot, I need to look into that. Been teaching calculus too long where we definitely don't care. If you wanted to fix that, do you know how you would fix it? How would you make that denominator cube rootable? If you multiply it by itself, look at this one, you'd end up with n to the 4/3 in the bottom, and you still have a problem.
Multiply by itself twice. Reciprocal.
No, not reciprocal, because reciprocal you would add 2/3 and 3/2, so that wouldn't help. You'd have to multiply by n to the 1/3, because then you'd get n to the 3/3, which is just n. I don't think we do that. I think we're going to be okay with this.
Calculus is
I need to look into that. Yay. That does feel easy, though. I would need 4 more, right, in order to take the 5th root. Yeah, I didn't look it up to see what kind of answers we want today. Right, so if we wanted to fix that, we would need to multiply by the 5th root of x to the 4th, so that we could then take a 5th root and get x down there.
which would be
I need to talk with Miss Houston and see what we want, what we're looking for. It would be a good bonus question. It'd have to be worded carefully. Right? Answer without leaving radicals or fractions in the denominator. Okay. Today's assignment is this next worksheet, because we are not doing the book work. This is Tuesday's assignment. This next worksheet. It is all. Remember, tomorrow, what's the plan tomorrow? Right, go to the Commons and work on this worksheet. The next worksheet is kind of the same type stuff. There's a few crazy ones on the next worksheet, but it's just more practice of the same stuff. So this will be Thursday's assignment. That next worksheet. And what do you do Friday? What are we doing Friday? Not reviewing. I'm not reviewing. You,
I'll be reviewing.
that's right. We're sleeping. We're going out of town. We are not here Friday. Yes.
I'll review with my work.
You're going to review with your family. I don't believe that. Sorry.
I'm going to review family topics, not topics.
That's fair.